everybody, hello world, hello Philippines. I'm gonna have my vlog or live stream pertaining to how to derive the theory of relativity and in conjunction or relation to quantum mechanics. But before that, I want to tell you guys that I want to cheat. I want to eat this junk food. Oh my gosh. Okay, before I will start the vlog, I will eat first. It's cheating time. Okay, so we have the formula of the theory of relativity equation. Capital E is equals to the mass of an object times the velocity or the speed of light. Okay, so this is referring to the particle, or shall we say a light particle or a photon, something like that. Okay, so I need to derive why that E is equals to mc squared is, the equation we will be able to use to compute for the energy. The theory of relativity discovered by Albert Einstein. Huh? Mukha ako. Hello, everybody. I'll cheat. I'll eat junk foods this time. Before I will start the vlog. Okay. Plus Diet Pepsi. Oh, I crave for this for a very long time. So, our topic is how to derive a theory of relativity in relation to quantum mechanics discovered by Albert Einstein, right? Shout out to you, Ma'am Gretel Bacalso. Oh my God. Okay, thank you so much for watching my live streaming this moment. Okay, I'll show you. Wait for a while. Wait for a while, guys. So I need to get a pencil pen. Oh my gosh, for the particular equation that I will be showing to you. So this is again quantum mechanics, right? So again, okay, so where's the paper? Scratch paper. So this one. God. So E is equals to mc squared. This is the theory of relativity equation. Okay, capital E is an energy of a particle or an object, or shall we say, a light particle or a photon. The capital E, energy. So it could be expected that the unit will be joules, equivalent to Newton meter, something like that. It depends on the unit. Okay? And then M is the mass in kilogram in metric system. So if your mass is in kilogram, then your velocity, okay, will be used is meter per second squared. No, meter per second lang siya. Because acceleration is meter per second squared. Velocity, meter per second. Okay? It's gonna be like that, okay? So now, okay, so before discussing to you properly, we need to correlate the different scientists and their contribution so that we can really understand the to keep track their discoveries because they are related with each other. Something like that, okay? So this is the theory of relativity I will write. Okay? Theory of relativity, okay? Theory of relativity. Okay, so I must put constant also for this ha. C is the velocity, as I told you a while ago. C is equals to 3.0 times 10 to the 8 meter per second. Okay, like this. This is the speed of light. Okay, it's very huge number. So in order to, for example, in order to travel very fast, almost closer to the speed of light, our time and space must be imaginary. Okay, you need imaginary time and space to travel as fast as this value. So this is the time that the time and space will no longer be relevant. Okay? If you want to travel closer to the speed of light. Okay? And this is also in the manner that time requires infinite energy. Okay? To accelerate in the outer space. For example, if I will discover, not discover, if I will make a spaceship, right, and going to the outer space, okay, your time will be irrelevant already or negligible, okay, because it requires an infinite energy, okay, to accelerate your spaceship into the outer space. Okay, the time is no longer relevant. You cannot compute the time. Okay, you cannot compute the time, what days, what months, what year, for example, you will go to the outer space. Because in the theory, it states that it needs an infinite energy to accelerate, okay, the spaceship or any objects in the outer space or in the universe. Okay? So meaning to say, time is irrelevant or negligible already. We cannot predict. It's already uncertain. Okay? If anybody wants to go to the outer space, you cannot predict what time you will be there. You get the point? You cannot predict. It's totally different when you ride an airplane. It's totally different when you ride a helicopter, a ship, a boat in which you can predict and you can target your time or day when you will reach for that particular destination. But for a spaceship, there's no specific and certain time what time you will land there. You get the point? Because time needs sufficient or infinite energy to accelerate the spaceship to the outer space. Infinite meaning walang katapusan energy. Meaning very fast. Like that. Just like a missile, something like that. And we don't know. Maybe seconds, minutes, and 1 hour. So we cannot compute experimentally. We cannot compute mathematically when at any time t your spaceship or your missiles will land to a particular destination or to a particular target because of the quantum mechanics principles in the universe that it requires an infinite energy, okay, for the time. So like that, imagine infinite, so immeasurable, walang katapusang value. Now if you want to travel as fast as the speed of light, which is 3.0 times 10 to the 8 meter per second. Now, time and space also are irrelevant. You cannot also predict the time. So, imaginary. You get the point? So that's why in the equation of this quantum mechanics, time is not necessary, as you can recall. Okay, because of this theory. Get the point? If you remember the uncertainty theory of Werner Heisenberg, it doesn't involve time. If you remember the Planck's equation, it doesn't involve time. You get the point? The Boltzmann constant or the Boltzmann equation, it doesn't involve time also. Remember? Okay? So it doesn't involve with time. So time and space is not really necessary for this. Okay? So going back to the main topic, which is the derivation of this cos E is equals to mc squared. Now, okay, we should remember the contribution of, before going further, okay, the Niels Bohr, number one, scientists. Okay, so in this contribution, we can really understand. Okay, that's why we need to, we need to name scientists and their contribution so that we can understand. Okay, you got the point? Meaning, we need to scrutinize the history of the scientific discoveries, why this evolved, or why this appeared for our textbooks, or why our teachers taught us for this, topics. Okay, something like that. Okay, it's not enough for the equations and formulas. We need to know really the actors of these discovery or scientific discoveries, right? Number one, Niels Bohr. Okay. I don't have to chronologically state the year. If I can remember, I would, but if I cannot already recall, just leave me to state it generally, right? Okay. Niels Bohr. Okay, shout out to you, Mom Isabel Sequoia. Okay. Number two, we have Max Born. Okay. Born dili sunog Born. Okay. Number three, we have Mr. Schrodinger. Okay. Schrodinger. Number four, we need also to know and to account the contribution of, okay, Mr. Kurt Lewin. Very difficult, right? Kurt Lewin. Okay. Mr. Kurt Lewin. Some of this I already memorized when I was in college, but the others are additional only based on my research. Okay. Mr. Kurt Lewin, something like that. The spelling is like this, right? Lewin, something like that. Number five is, of course, Mr. Planck. Okay. Mr. Planck. Okay. Mr. Ludwig Boltzmann. Okay. Sorry. Mr. Ludwig Boltzmann. Okay. Like that. What else? Mr. Simon Nernst. Okay. Mr. A lot of scientists, right? Mr. Simon Nernst. Okay. What else? Michael Faraday. Okay, Michael Faraday. Number 8, Michael Faraday. Michael Faraday. Okay. Uh, Mr. John Maxwell. Okay. Mr. John Maxwell also, if you can remember, for his contribution of electromagnetic radiation. Okay, Maxwell. What else? Mr. Avogadro, right? Avogadro, something like that. A lot. Sobrang dami na. I have already 10, right? Okay. We have also Mr. Werner Heisenberg. Okay. Mr. Werner Heisenberg. I love this. In first year college, I already memorized this theory of Werner, but due to research, I added more. just recently, just presently. I researched more how to derive the equation, blah blah blah, so and so. Okay, but the theories I already discovered this when I was in college. Mr. Werner Heisenberg. Okay, like that. There's still a lot, Mr. Haber process, Mr. Lee Chatelier, Mr. Rialts, Mr. Henry, something, a lot. Okay? And we have also, of course, mga bunong na ni siya, Isaac Newton, Albert Einstein, something like that. Okay? Albert Einstein. Okay. Guys, who is the father of modern physics? Albert Einstein or Isaac Newton? I forgot, but I think the one who has a great contribution into physics is Isaac Newton, right? His laws on classical mechanics and laws of motion, three laws of motion. Okay, but Albert Einstein also really is brilliant scientist because he discovered also the light and matter, energy, behavior, something like that. Of course, the theory of relativity, something like that. Okay. What else? Louis de Broglie. Mr. Louis de Broglie. Okay? Louis de Broglie. Okay? De Broglie. Okay. And then Mr. Paul Dirac. Number 15. Grabe kini si Paul Dirac. Mr. Paul Dirac is a scientist who is brilliant and at the same time he is also very what do you call this one? Kiat, sipat kaayo siya. Okay, magbugoy-bugoy siya ba pero genius siya. Something like that. And then, maglagot si maglagot si Newton niya from something like that. Okay? Si Albert Einstein pala. Okay. Maglagot sila with this guy because he can still learn too much even though he didn't study a lot, something like that. So his intelligence is very natural. Okay, something like that. Okay, Paul Dirac. Oh my gosh. Okay. There's also Mr. Offbau. I forgot the first name of Mr. Offbau. You know that one? Offbau and Mr. Hand. Okay. Mr. Hand. And Mr. Pauli, P-E-U-L, forgot the last name. Okay, based on my technology, it's gonna be like this, but forgot the last name really talaga. Okay, and Mr. Compton. Wow, dami! Nakakaloka na no? Mr. Compton. Masa may discover ni Compton? Uy, charot. If you try to be serious, makabuang biya siya. Okay, but we need to learn lang yun sa mga basics. So there are at least 19 scientists. Okay. Oh my gosh. That played a great contribution to science, particularly to physics, quantum mechanics. Most of their studies on light, matter, and energy. Okay, something like that. And most of them agree that matter has a wave function or a wavelength, not just a particle, something like that. Okay, so meaning to say, wave particle duality. They can act, matter can act as a wave and can act also as a particle. Because what we understand in chemistry, that this matter only acts as a particle. Okay, it will never act as a wavelength, but or don't have a wave function. But it's in physics that we study the wave function characteristic of this matter. Okay, get the point? Matter is anything that occupies space and has mass. So basically, these are the solid, liquid, and gas that comprises the matter. Get the point? So anything that has weight, okay, or mass. It depends on the situation what you're referring to, if you consider the gravity or not. If you consider the gravity, then you have to refer to weight. Okay, then weight will be equal to the force directed downward. Okay, the force directed downward will be equal directly to the weight if you are considering the gravity. But then if you will not consider the gravity, then it's not an issue. Force will never be equal to the mass. Get the point? But weight will be equal to the force. Get the point? So it's the reference point. Okay, going back now. So our main target is this one, E is equals to mc squared. But I need to discuss more on Mr. Lowy de Broglie. Charot. Actually, Mr. Lowy de Broglie comes ahead than Werner Heisenberg. He is on 1927 he discovered, okay, 1927 he discovered the wavelength of an electron. Wow, bongga. Wavelength of an electron, okay? Because in the quantum mechanics, okay, what are being specified there are the photon and the light particles only that will behave as a wave as a particle, but the electrons also specifically can behave also as a wave. That's why Mr. Lowy de Broglie discovered this in 1927, the wavelength of an electron. Okay? So marunong sila, if they discover something, they will also carry the other scientists in their formula. Really. Okay? So meaning, they're interconnected with each other. Okay? Just like Mr. Max Born. Mr. Max Born considers also the postulation or the theory of Mr. Schrödinger regarding the three-dimensional analysis of the wave functions or the wavelength of an electron or a particle, something like that. But he added the amplitude. Okay, the amplitude, the vertical distance, and the positioning through probability distribution. Okay, when this wavelength travels from point A to point B, it will have different positions at different locations interval, and then you can determine if it's having a high probability distribution at the top, okay, lowest probability distribution at the bottom, okay, something like that. And if this peak and trough will react with each other, it will produce another wavelength, okay. Okay, in physics, you remember, the peak will be our, positive, and our trough will be our negative. Positive and negative will react to produce one wavelength, right? So this is in superposition with each other. Quantum superposition. Okay, remember? So like that. So it's gonna be the wavelength and this amplitude. Max Born discovered the amplitude. Okay. So when he discovered the amplitude, that's the time also we can apply the Pythagoras theorem of right triangle. Sa ganito sa algebra, c squared or hypotenuse squared is equals to the square root of the opposite side raised to the power 2. Okay, ganun siya. Plus the base raised to the power 2. Okay? And then the hypotenuse will be the square root of these two quantities, and then you can compute for the hypotenuse. Okay, like this. So originally, hypotenuse squared is equals to a squared plus b squared. A will be your opposite side, b will be your base, and both of them will be squared. And since you are only interested with the hypotenuse, which is hypothetically the letter c, then you can take the square root to eliminate the exponent of the hypotenuse. Then you can solve for the value of c, the hypotenuse. Okay, and there's also, if there's an angle chuba, you can use the arc tangent theta is equals to the opposite side over the base, and then you can compute for the angle, right? And then you can also compute for the radian values in terms of pi, chuba, okay, pi. Get the point? These are all very basic in mathematics that if you try to inject this in our brain cells, we can really compute how to compute the angle of inclination of a certain particle that will travel, something like that. Okay, so it's very easy for us to postulate, shall we say, a new derived equation if we correlate several equations also. Okay, you get the point? Something like that. because it's really gonna be like that, the combination of science and mathematics really all the time. Okay? Mga biglaang derivation of formulas na we never encounter pa, and then we'll be the one to derive by ourselves. Okay? Something like that. For example, a theory of relativity is equals to the Planck equation constant. Okay? And then you treat them as equal in a steady state flow in the particle theory. So you can equate both energy, right? Energy of a photon is equal to the energy of the light particle or electrons. They equate mo siya, since you know the formula of theory of relativity, and you know also the formula of Planck constant, okay? With regards to the momentum and position, then you can compute, you can have another formula also. Okay? It's gonna be like that. So you should have a wild imagination and critical thinking. Charot! Mukhaon sa kukuan eh. Gutom jud ko eh. Fairness. Okay. Going back. So, usually guys, the derivation of a formula or equation comes from a complex equation and a complicated formulas and equations. When you derive something, it is expected that your output equation or your final equation is already simplified. Okay, very easy to understand and no such complications in your actual formula. Just like this Albert Einstein, right? E is equals to mc squared. I will derive this one, okay? And then going back to Mr. Louis de Broglie, he discovered the okay, de Broglie wavelength. Wow, that's a special name for him, de Broglie wavelength, because he said if the photon, the light particles, travels in a wave function or a wavelength, then of course the electron also will travel as a wave, as a particle, and just like the quantum, of light, something like that. Or energy travels in a discrete particles or packets called quanta. Okay? So, Lowe de Broglie create a formula, a very easy to understand formula, okay, which is equal to the wavelength of an electron. Take note, electron ha, specifically I'm not saying yet a photon. Okay, electron. Okay, wavelength of an electron is equal to the Planck constant over the momentum. This one. This is the Lowe de Broglie equation, a very simple one, right? This wavelength of an electron is equals to the h, small letter h in the numerator, which is the Planck constant, equal to 6.626 times 10 to the negative 34 joules second over capital P momentum. Momentum is designated as capital P in physics when it is mass times velocity. Now, velocity can be expressed as small letter c and small letter v. It depends on how you treat that in your derivation. But let's just assume to use letter c because this is the c. Albert Einstein is using this one. Okay? This is only representation. In here, is equals to mc squared. Okay? C is the velocity or speed of light. So let's just put velocity here as letter C. Okay? Ganon-ganon siya chararat. Okay? Now, if we have this theory of relativity, it comes from a complex equation of special relativity. Wow. Special relativity is equal to E squared raised to the E raised to the power to energy raised to the power 2. Chararat, wait. Ganun siya. Wait for a while, guys. Uy, bukaon sa tupuan. Char! Sige lang kaon. Hello, guys. Okay, E squared is equals to... Oh my gosh. Okay, the rest mass of a light. Okay, so MO. Rest mass ang tawag niya ha. Raised to the power 2 times velocity of the light raised to the power 4. Wow, bongga. Plus the momentum raised to the power 2 of an electron because we are computing here the electron manggod siya. So in here, both the electron and a light in special relativity. Okay, again, in a equation of special relativity, both the light and electrons are considered. So meaning to say, the energy here, special relativity, capital E, is either a light or a photon and an electron. Okay, so times velocity squared. Ganun siya. It looks like complex, right? So capital E raised to the power 2 times the rest mass of the light times the velocity of the light plus the momentum of the electron raised to the power 2 times velocity raised to the power 2. Okay, ganun siya. Now, by theory, according to Albert Einstein, okay, the rest mass of the light is 0. Okay, theory. Now, if that is 0, it will be cancelled already. It will become 0. This is a technique all the time. If you know the constant, then it's easy for you to derive. Especially if the one of the variable is 0, gagana siya, chupa. Okay, so it will become 0. So what left here is equals to E squared uh, P squared C squared. Again, P is the momentum, mass times velocity. Okay, ganun siya. Okay, guys? Okay, ganun siya. Now, we have, since we are considering light here and electrons, right? We have also the formula of the light particle of a photon discovered by Mr. Planck. Okay, that energy is equals to the Planck constant times the frequency of the light or light particle. Now the frequency will be cycles per second, okay, or it could be period per second as the light particle travels, something like that. Okay, or it could be period per second. It depends on the situation, what you are trying to measure the wave experimentally. Because most of the quantum mechanics studies, discoveries are based on experimentation or experimental, something like that. Okay, so it's gonna be like that. So E is equals to H, capital, small letter H. Planck constant is always small letter H, ha? Okay, times the frequency. Frequency also, guys, is always small letter F. So this is our equation, equation 1, equation of the wavelength, lambda. Equation 2, our capital energy for the special relativity. Equation 3, where it will be the, okay, Planck's equation. Equation 3, o ganon. Okay, we need only 3 equations to derive this E is equals to mc squared by theory of relativity of Albert Einstein. Okay, ganon. Now, so equate, assuming this behaves in a similar behavior because both of them follows the theory of wave-particle duality. You know, in quantum mechanics. In quantum mechanics, it's very important to understand the wave-particle duality, which are the photoelectric effect experiment, okay, and the dual slit experiment. Okay, there's a little bit opening, and then the electrons will go there, and the lights will go there, and then there's a light, a beam of light, and then it will produce, you know, a wavelength like this. Okay, and then it will hit to the screen. Okay, when it hit to the screen, it produces a lot of wavelength function corresponding, you know, what we call this one? Probability distribution or specific location, positioning, or something like that. Okay, so i-equal mo siya, equate 2 and 3. Okay, related man siya. So it's gonna be, okay, HF raised to the power 2 is equals to capital P raised to the power 2C2. Ganon, guys. Okay? Makita ninyo ang papel, mabasa ninyo, dili. Okay? So, Planck constant times frequency raised to the power 2 is equal to momentum raised to the power 2 times the velocity raised to the power 2, velocity of the light or the velocity of the electrons. It depends on what you are computing. Okay, as long as that is a particle. Okay, but because this is not applied to macro materials or macro objects. This is for micro particle or subatomic particles, chuba chuchu. Okay, you get the point? So this is not applicable to the macro because macro objects having certain, position and momentum. That's why we studied here because it's very difficult to predict and to determine the position, the momentum of these particles. Okay, that's why we have uncertainty value of position, momentum. Okay, if not, it's very easy to solve without experimentation if you can see directly in our naked eye. Okay, you got the point? So it's gonna be like that. Now guys, if you see an equation like this, all are raised to the power 2, of course, we need to avoid the exponent by multiplying each side to 1/2. Something, algebra. Okay, always like that in algebra ha. Basta na yung mga exponent, you multiply to a certain exponent that would cancel the exponent so that what will remain? A single variable. Easy and simplified. Something like that. Okay? So that is the rule of thumb. Okay? Always in mathematics and science. Okay? So F siya is equals to P, C na lang siya. O, simplified na kayo siya. So Planck constant is equals to the frequency times the momentum times the velocity C. Ganon. Okay guys. Balikan na to ang HF. Kung sagot ng HF, di ba energy siya? Okay, so HF is energy. Okay. And then we have also PC, mass velocity of momentum times velocity. So what is the formula of momentum? Mass times velocity. So I could say mass times C, right? This momentum. Okay, and there's still another C left times C pa siya. Okay, so this will equal now to E is equals to mc squared, in which Albert Einstein equation arrived. Right? So it will become now E is equals to mc squared as the general equation of the theory of relativity discovered by Albert Einstein. So it comes from a correlation between the special relativity, okay, and the Planck's equation considered, okay, something like that. Now, we don't forget also the wavelength of an electron here, which is Planck constant over the momentum. Now we can compute also the wavelength or the Planck constant or the momentum or the velocity in terms of this equation here nga nakuha nato diri. Here, we go back to the equation in which hindi pa siya simplified. Okay? Or else, we cannot solve anymore if you go into the final output. So, we leave this HF equal to PZ is our equation number 4. Something like that. Okay, so Planck constant again. Planck constant times the frequency is equal to the momentum times the velocity. So this is our equation 4. Now use this equation 4 to correlate to equation number 1 that states wavelength of an electron is equal to the Planck constant over the P. Now, try to equate and do something to simplify these two equations. Okay, I'll show you. And compute for the velocity, compute for the wavelength, compute for the momentum, and the rest will follow. Okay? It's gonna be like that always, huh? Okay? So, because there are books also that will not show the breakdown of how it is being arrived. Okay, we will go directly to the result, and we will wonder where it came from. Oh, like that. Then we have to still go to another topic just to protect the basic equation for the particular quantity or whatever, chuba chuchu, right? Okay. Wavelength of the electron is equal to the Planck constant over P. Again, sa ganito, this one, discovered by Mr. Louis de Broglie in 1927, 19th century. Again, in 1927, in 19th century, Mr. Louis de Broglie discovered the wavelength of an electron equal to the Planck constant over the momentum. The Planck constant, small letter h, is equal to 6.626, something like that, raised to the power negative 34 joules per second, and the momentum will be equal to the mass times the velocity, okay, of the particle considered. Particle meaning elementary particles could either be electrons, protons, neutrons, positrons, photons, bosons, okay, fermions, quarks, leptons, okay, electron neutrino, tau neutrino, like that. A lot of elementary particles, okay, subatomic particles, a lot, okay, baryons also. So these are subatomic particles. Okay, we're not limiting only to the three atomic particles that our teachers in elementary education that taught us. We need also to dig pa. Mayroon pa siyang mga sobra kagamay. Okay, like that. Okay. So later I will be discussing also how that behaves. Charot. Kaloka. Okay. So, ganun siya. So, wavelength, okay. Sometimes, I remember also in the board examination, it came out, the positive electron. Wow. A, quark, B, lepton, C, like that. Okay. Then I answered, of course, positron. Positron is a positive electron. But what people believe always that electron is a negatively charged particle, but it's not. It can behave also as a positively charged particle known as positron. Okay? And positron will also produce rays or emission just like the beta particle. Okay? Something like that. Okay, the beta particle are mainly the electrons, right? Just changing the term. Beta particle, or we have electron using the positive for that. Positive electron is the positron. Okay, so the answer will be positron. As easy as that. Okay, blank is a positive electron. A, proton. B, neutron. C, like that, the choices will be then positron. Okay, like this. So really, it will come out the basics really, okay, but not so many. There's only few will come out basics in the board examination. Okay, but not all the time. Okay, but there's a lot, not really lot, balance theories talaga siya in science and in physical and chemical principles. Okay, if you are taking Bachelor of Science in Chemical Engineering, okay, it depends on the course kasi eh. Okay, because chemical engineering a lot on sciences kasi due to the word chemical. Okay, the root word is chemistry. Okay. Okay, disclaimer na naman. Okay, somebody are saying that in studying BS Chemical Engineering, we're studying more of physics rather than chemistry. For me, it's not. Okay, if that is the case, our course will be called physical engineering. It's not physical engineering, right? It's chemical engineering. Meaning to say, a lot of chemistry. That's why chemical engineering. You get the point? But others, I don't know if they are really engineers already or whatever, chuba chuchu. They said, if you want to study BS chemical engineering, you will be wrong if you're just good in chemistry. No, it's not. Okay? Like that. It's an advantage that you are good in chemistry. Because some of the physics topics also will be discussed in chemistry, somewhere in the last part. This quantum, this blah blah blah, particles. Okay? So, chemical engineering. Chemical stands for chemistry, not physics. Okay? If not, BS physical engineering. Because of the word physics. Right? So, it's not chemical kasi eh. Okay, so I contest, I object to those people who will say it's more of physics rather than chemistry. Okay, that's very clear. And take note, when you go to unit operations and physical separation processes, a lot of particles and substances to be discovered there, such as the distillation, flotation, crystallization, evaporation, heat transfer, and it's more on chemistry. Really, it's not more on physics. The physics is more on light and energy when siya. Okay, matter and energy. Okay, yes, it's studied in the thermodynamics, the energy, they hit all kinds of energies, but those energies discussed also in chemistry lecture, the internal energy, the heat energy. So not only discussed in physics, but prior to that in chemistry. Okay, so for me, if you have a solid background in chemistry and mathematics, and even though you are not very good in physics, it will be okay. Mm. Okay, but I disagree that somebody will say, if you are good in chemistry, nagkamali ka daw sa pagkuha ng chemical engineering. No, it's not. Okay? This is very useful all the time. Especially the law of conservation of matter, law of conservation of energy, okay? Law of conservation of mass is always used in unit operations, in momentum transfer, in transport phenomena, okay, and in physical and chemical separation processes unit operations. Okay, it's not really that always physics. Okay, you get the point? Because we're not always studying the motion there, motion and behavior. Okay, there's a lot of chemical reactions also. And remember also, guys, if you take BS Chemical Engineering, the heart of chemical engineering is the chemical reaction kinetics or the chemical reaction engineering. You get the point? That's the center of study in chemical engineering. Just like if you have a cement plant, the heart of a cement plant is the kiln process. Kiln, K-I-L-N. The burning, the pyrolysis at a higher temperature to produce a very well cooked, okay, raw material to produce your product. Something like that. It's just like that also in chemical engineering. Okay, chemical reaction kinetics. Okay, so we need to design a nuclear reactor. Okay, like that, chemical reactor design. So really, okay, it's so chemistry will be used more in kinetics, how fast or slow the chemical reaction really is. Okay, that's the center in chemical engineering. That's why conversion of raw materials to useful products. So that's chemistry already because conversion and transformation. Then why you will say physics is more important than chemistry in studying chemical engineering? It's not. Okay? It's because we deal with raw materials, conversion and transformation of raw materials with its corresponding parameters and operating conditions. For example, temperature, pressure, volumetric flow rate, mass flow rate, okay, density, pressure before pressure, density, boiling point, kinetic energy, something like that, specific gravity, okay, like that. So a lot, right? Those are parameters. Then we feed that in our input, like that, raw material, and it will be converted. The raw materials will be converted to a useful product with the application of technology, okay, equipment, high technology, and then plus mathematics, okay, the application of mathematics, computation, okay, and then the science involved also in it, the chemistry in how it will be able to transform to another product, from gas to liquid, from liquid to solid, because the products are always like that. Every product we face is always undergoing physical and chemical separation processes. It's really chemistry, okay? The moment you wake up in your bed, it's already chemistry, not physics. Okay? You breathe oxygen, it's already chemistry around you. Oxygen, nitrogen, okay, that God gave to us. Water is already a chemistry. Okay? When you wake up. Okay, you got the point? You got the point, huh? Very clear. And also the physiological chemistry inside our body. That's why we urine in the morning. Okay, we drink water. Okay, because we need oxygen for the chemical reaction in our biological synthesis inside our body. Okay, for our energy so that we'll become healthy. That's also chemistry. Okay, so it's not physics. We don't compute velocity. Okay, the velocity of protein, the force of protein, calculate the force of protein will go to the kidney. Wa may ana siya. Okay, but it's always what is the concentration of your hemoglobin? Oh, it's already chemistry. What is the concentration of your cholesterol level or sugar? That's already chemistry. Okay? So our health needs the study of chemistry in order for us to survive. Okay? And chemistry is the basic tool in medical science because of the formulation of medicines, syrups, vaccines, or whatever. It's already chemistry, guys, not physics. Okay? So I object to those people who are saying that in studying chemical engineering, it's more on physics. For me, it's not. Subjective, ha? That's for me. Okay, not for you. Okay? And just respect. Or if you, again, object me, chat me in my FB Messenger so that we can discuss it in a healthy manner, in a professional approach. And let's present facts, okay, in our discussion. Okay, because again, the heart of chemical engineering is chemical reaction kinetics or chemical reaction engineering. How fast or slow the chemical reaction really is. That is very useful in the conversion of the raw materials to produce the products. And all products around us, the paper, the laptop, okay, like the metals, the plastics, the rubbers, the tupperwares in our kitchen, all made with chemistry principle. You get the point? Okay. Going, ako yung explain. Okay? So meaning to say, without chemistry, we will die. Because the universe itself is already a chemistry. Okay? Nitrogen, oxygen, helium, ganon. Okay? Helium, because sun produces helium for its energy also. The second lightest element in the universe is helium, second to hydrogen. Okay, hydrogen is the lightest molecule discovered by Henry Cavendish. Okay? Oxygen discovered by Jules Priestley. Something like that. Okay? Okay, going back. So wavelength of electron is equals to the Planck constant H. Sobraan yung pronunciation ni Sotero. Okay, so momentum. Charot. Okay. Kakaloka. This one. This is equation number 1. Wait, time check. Bruto UV powder Alaska milk na. 96.3 W rock. Pagaw. Kakaloka. And then our equation here, number 4, HF is equals to PC. This is not a PC, ha? This is not a personal computer. The PC here is momentum times velocity. Okay? This is not also polycarbonate. Because PC also, the brand name of the organic chemical known as polycarbonate. Okay, something like that. In polymerization reaction, in organic chemistry. Okay, in making Tupperwares, okay, lunchbox, plastics, rubbers. So those are involving the principle of organic chemistry. Okay, without organic chemistry, we don't have Tupperwares. Okay, because the combination of those products are made with the principles of organic chemistry, undergo a lot of chemical bonding and chemical reaction to make it hardened, the material of a Tupperware. Okay, so it involves also a lot of processes there. Okay, melting point, boiling point, crystallization, ganon, sobra. Okay, and in fact also drying, right? I forgot how to compute the drying constant in unit operations. Oh my God. I love that. Charot! Kaya paborito dyan ako sa chemical engineering kuan man, heat transfer. I love heat transfer and also a little bit of chemical reaction engineering. I love chemical reactions talaga. Okay? Charot! Charot lang. Kaya naman dito yung mga paborito, di ba? If you take that course, there are also subjects that we like the most. For me, I like the most for those subjects like that. Okay? Of course, the basic foundation is chemistry. I love chemistry too much. Okay? So it's H times F is equals to P times C is equals to 4. Equate 1 and 4. Uy, sorry kayo, Engineer Timoteo Edulantes, ha? Sorry kayo. Okay. By the way, Engineer Timoteo Edulantes is my classmate. Okay. In chemical engineering of Cebu Institute of Technology University. He took up his masterals in physics. Sorry. Nya ako bang discuss ang chemistry is more on chemical engineering, but brighter ba kayo ni si Timoteo, baka mas palpal ko ani niya. Okay? So he's taking the Masters of Physics and he's now one of the instructors in UK. Tama ba ko? Engineer Timothy Dolantis, University of Wales, right? Teaching science, right? Physics and in chemical engineering. Am I correct? Okay. So I think, bright kini siya. In fairness niya, niingon ra ba ko nga ang chemistry is more important than physics instead in chemical engineering, but mas tiral ra ba siya o physics? Charot! Shout out ha, sorry kaayo, kaya ako naman ang subjective ba ya, my own opinion naman good. Okay, so 1/4, equate 1 and 4. Okay, like that. Okay, so now if we try to substitute values here, okay, for example, solving for the value of h, h is equals to, ganun siya chuba chuchu. Ganun. So there's also h here. If you try to equate, troubleshoot the common. Okay, 1 and 4. The common quantity is h. Because this letter h, Planck constant, are found in equation 1 and equation 4. So this is very important now. Solve for h because this is common for the two equations. Okay, so h in equation 1, algebra, cross multiplication, this will equal to h is equals to the lambda e times the momentum. This one. Okay. Planck constant is equal to the lambda e times the p. Okay, from this equation. And h also here we can calculate as, nakakaloka, h is equals to p c over f. Ganon. Okay, this guys. For the equation number 4 also, like that. Okay? You got the point? Now notice, the h and the h, let's say this is equation number 5. Ang dami ko ng equation. Equation number 6. This one. Number 5 and equation number 6. Okay, what do you notice? They are both the same quantity, right? H, h. So we can equate the 5 and 6. Okay, so lambda e times p in equation 5 is equal to the PC over the frequency in equation 6. Okay. Now, sigahon dayon yung imong mata. Nga, pagtanaw dayon nimo, unsa may pariho? Okay. If that is the same, then cancels that out to simplify your equation. Yung anak ito yung mga kwanha, mga engineers. Okay, so P, cancel. So what is left now, class, is lambda E is equals to C over F. So since we know that C in the first place, that is the velocity, so we can compute for the formula of the velocity to calculate the speed of an electron, the velocity of an electron that will travels. Okay, like that. So if the question in the problem solving in the future asking for the velocity of the light, velocity of the photon, or the velocity of the subatomic particles, you can compute by having the frequency, okay, and the wavelength of the particular particle. Because it's not limited to electron manggod. Electron only is just our example here. It could also be the proton, the neutron, the positron, the photon, the fermion, the lepton, the boson, the quark, something like the baryon. So these are subatomic particles. Okay? So you can change your subscript now of what is being asked because both particles or all particles of matter will behave as a wave function or undergo wavelength through wave-particle duality principle. You get the point? Through the experiment of dual slit experiment. Experimental magudi siya. Okay, something like that. So our wavelength now will become, wavelength of the electron is equals to C over F. This is our equation number 8. Ang dami. Now for the velocity, equation number 9 is equals to velocity wavelength A times F. Ganun siya. Okay. This one. Equation 8, equation number 9. So you can compute for the wavelength of the particle. You can compute for the velocity of the particle. Okay. Now, since we derived already the mc squared by Albert Einstein here, what you notice, there's also letter C, right? So what equation here in 8 and 9 have letter C? All 8 and 9, right, have letter C. Compute also for the C in equation 8 and equation number 9. Substitute that to the theory of relativity of Albert Einstein. You can get also another equation here. This is not discussed in the book. Okay? Now only. Okay? Based on my calculation I obtained here. Okay? Then I obtained here, there's a C. Then it's possible also that you can substitute that in the general theory of relativity equation of Newton just now on the spot. Okay? You got the point? That's why I told you, you can create your own formula by correlating all the basic formulas you've understand already in science. Do not be dependent on your instructors and do not be dependent on the books. Okay, because the books also are not showing everything. You have to make your own talaga ta, assuming that it's valid, realistic, okay, something like that, and meet the basic foundations and principles of physics, chemistry. Physics and chemistry all the time, right? It's gonna be like that. You got the point? Okay. Pero nakasuway man jud ko ani in taking the chemical engineering board examination that there's no really formula I've met in my entire life in my fifth year college. And I keep on gathering the equations. Wala gyud siya. Okay, then unsa man akong gamiton ani? Then I found out ako siyang gi-equate dito. Muna akong gibuhat karon in the actual chemical engineering board examination. I did it also before. And then I create another formula and I substitute the values there. And it took me a long time just to derive for that formula as far as I could remember. Okay? That was the last I solved. Actually, I stopped solving it. Okay? Because mahurot akong oras kung ako to siyang solve o dugayon dito na ako. Ni-proceed ko sa mga sayon-sayon. Now, ako siyang gibalik in the end sa katapusang hugna. Sa katapusang hugna, ako yung gipaning kamutan ng makakuha akong equation. Kaya anak mo akong personality. I want to dig it out if I cannot understand. That's my character. Okay? If I cannot understand, I cannot sleep. Really, it comes on my mind. I cannot sleep properly if I cannot understand certain situation, certain things. I want to have clarity before I sleep. Okay? Something like that. That's my personality. So, that kind of personality also applies when I study in college. For example, if I cannot solve this, I will not leave that behind. I really solve that. If I cannot solve that one, I cannot sleep. Something like that. Okay, so I have that character and personality. So it happens also in the actual board examination. That was the last. Then I was the last who went out in the examination room. Okay. And then my instructor, because he visited us, Engineer Amis Pakamalan, you know, our head of Cebu Institute of Technology University. Okay, he said, "Uy, Sotero, imo yung gitikti." Nasiyaw lang natin ko. Ma'am, lisod man gud kay tanan, ma'am. Diyos ko sabot. Ato. Ano ko na. Mo to ni gawas ko. Pagtanaw ko sa akong mga tupad, wala naman ako na nabilin. Okay, ako na nabilin sa bangko. Really. Sakto sa jugay na human ra ko, ako rin gipa sa proctor akong papel. Ganon siya. Okay, because Ma'am Ames is very supportive to us in every board examination. Okay? Our head of Chemical Engineering Department in Cebu Institute of Technology. Before, dili pa man siya university. Technology pa siya now, just now, become, in the 20th century. Wow, 20th century talaga. In the 2000 plus, it became university. Okay? Kaon sa kugkuan muna na siya ha. Kimana na to kung solve the problems. Okay? Mag-drawing pa kung taon. Okay guys, after ni Louis de Broglie, here comes another scientist named Werner Heisenberg. Okay, so Werner Breitzsky siya, and he postulated the, the uncertainties of both the particle position and the particle momentum. Okay, and again, the basis of his equation derived from wave-particle duality. Ano siya for me, guys, okay? Timan ang gyud nato nga wave-particle duality gyud kasagaran sa mga subatomic particles. Okay? Basta ha. Alo ka? May mukhaan sa kong banana. Rich in potassium. Wow. Sana only discover. Ako sa i-identify kung sino ang nag-discover sa potassium. Diba? Siguro kung ato nang dyan nang i-memorize ta na, matap-share yun ta, no? Sa board examination. Atong memorize, ato dyan kung anong tanan ba, ito ginato tanan. Ang mga kisay nag-discover sa calcium, ganun. Hindi mo na ito matabang, hindi mo na ito mapuantanan. Hindi na ito may balang tanan ba, no? Takuha mo. Labi na, di ka hilig og memorization. Then, mga multipod baya ka, in fairness. So, I advise you have to love memorization. But one technique to memorize is to understand first hand. Okay, and then read it 2 times, and then understand, and then memorize. Okay? Last ang memorize. First, you have to read. And then, if you cannot understand, read it again. And then, after that, understand. Like this. You have to connect other terms related to what you read. And after that, memorize. Okay? So, murag mo na siya hinungdan nga mo pilit sa brain cells ang inyong gi-memorize. Kinakasabot mo sa inyong gi-memorize. Okay? That is the point there of memorization. Okay? And science courses and our courses also, our course, BS Chemical Engineering, involves a lot of memorization. Okay? Especially in physical and chemical separation processes. And in, transport phenomena, okay, like that, momentum transfer, mass transfer, heat transfer, a lot of formulas to be memorized. Because there's no time already to derive. Magsigit kag derive, mahurot imong oras. Okay? Imo pa yung i-derive ang density. Masayon ra kaayo. Okay? So you should memorize na lang yun na. Sayo na kayo mapasok sa atong brain cells ba? Ato na lang siyang i-memorize. Okay? Naman ay technique, Jude. Wow. Naman sa usagay na, minisang na lang Jude ako, masapit ako nito. Charot! There are also times that when we read or we heard something, it will register automatically to our brain cells. Even though we will not memorize that one. Okay, it will just register. Okay? There are also things like that. Okay, I think it's gonna be 30%, 40% retention, but for 50% up retention in your brain cells, you have to memorize. Okay? What I mean, there's na mga bigla-bigla ang memorize nimo. Okay? Ibasa ka no, masudan sa mong brain, ganon. Yung nasa iyo sa high, di jud masud, kaya magtakas na kayo siya, lisod ba? Okay? Kalaw ka? Oh my gosh. Minikaon like brown bread, good for the health. Shout out Ma'am Maricel Cabaral for watching my science vlog and live streaming about the theory of relativity discovered by Albert Einstein, derivation in relation to quantum mechanics. Oh my gosh. Ano itong mga papel na ko eh? Hello guys! You're still there? Did you come kaon? Kung tiwas. Uy! Wow! Craving for Pepsi diet. Diet mo. Nag-diet man ko. Pepsi diet sa akong gipalit. Charot! Diba? Ay! Woo! Carbon dioxide. Okay? So I will explain. Charot. Science to siya. Because there's a pressure buildup inside the can. Okay? Then it stays for a long time in the refrigerator, and the built-up carbon dioxide has a higher kinetic energy in the top. It goes to the top of the can, and then when you open that one, the pressure will release too fast. That's it, like that. So supposedly, I forgot to shake, okay, to avoid that one because I'm talking. I'm out of my mind because my mind really is focusing on the vlog. Okay? Sige lang, eh. Don't mo na. As long as huwag mahulog kong explode. Char! Okay? Pressure built up due to high kinetic molecular energy or intermolecular forces in the, in the surface of the Pepsi, between the liquid water and the ingredients, blah, 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 so and so. Explain mo sa Einstrin. Okay. Pressure with shock. Okay. Diba? Pressure is equal to force over area. I apply the force, I open the can, right? And then when I apply the force, and this equivalent pressure, and it happens only that the pressure is very high. Okay, because of the theory for this. But I have to drink this one. Char! Kaloka? Hindi mo siya tamis. The Pepsi diet is not tamis. Hindi ko na tamis. Char! Avoided also glucose level and sucrose level in my system. Sige lang, trapo-trapo. Hello guys! Welcome to my live streaming. Again, this is I am a singer, Eternal Voice. Let's continue. Okay, ay. It's just like I'm doing a monologue, right? I'm talking with myself. And my viewers and my audience are, in the virtual platform of communication, online platform of communication. Yes, live streaming, okay? I don't have actual audience in front of me. It's just like a monologue, okay? Like that. Okay, now we'll introduce to you another equation, Compton equation, related to quantum mechanics, also related also to the wavelength, right? Okay, guys, if you will understand this, guys, equation number 8, this is wavelength of an electron, right? Yes, and it involves frequency. Here, we have also the Compton, Compton experiment, meaning the scattering of the light particle. Okay, something like this is like a fluorescent, right? A fluorescent, there's a barrier at the top. Look at the fluorescent, my light. So there's a barrier, so there's a light ray. The ray particles are called the photon. So when the photon will go there, it will be obstructed a little bit, okay, and then it will produce an erratic positioning in the screen, and then others will go out, something like that. Because it is very, very, very tiny. It can really escape even though it is a closed vessel or whatever, because it's very light. Okay, get the point? If not, there's no light for me now. If the particles cannot escape, aside from the diffraction, diffraction of the particles, okay, in physics. Remember that one? I think in chemistry, it's been told Tyndall effect, Brownian movement or Brownian motion, ganon, refraction, diffraction, interference. Okay? So it's about, wavelength, chuba chuchu. Okay, we have also wavelength of the light. We have light wave. We have also sound wave, sound wave that is very useful in the communication. This also employs quantum mechanic theory, sound wave. Anything about waves employs quantum mechanics. Okay, sound wave and a light wave. For the sound wave, it's very useful in the communication process in, for example, in video call, okay, usually something like that, your phone, that even you are very, very far away, you can hear his voice. So that study is being discussed in quantum mechanics, particularly the sound wave, okay, electromagnetic sound wave. And we have also electromagnetic light wave for this. Okay? So the electromagnetic light wave is very important because, for example, if the sun will produce a light, then everybody can feel it. Okay, it's not limited only for very close distance. All will benefit that light of the sun. Okay, the ultraviolet rays or light of the sun or radiant heat of the sun. Okay? So, ang transfer ano niya guys is heat transfer through radiation, through radiant heat by the sun. Okay, something like that. That's why we will receive the light of the sun. Okay, composed also with helium. Helium and hydrogen. Okay, something like that. That's involve also the quantum mechanics again. Okay, employing the fusion. There's a lot to discuss. Like, I cannot discuss some because charot. I'm not going back to school. Charot. Charot lang. So if I am if my career now is a platform discussion. Hi, Mr. Jovan. Thank you for watching. Okay, ganon. So, Compton scattering. Okay, in here, photon and electrons combined. Okay, in this study. Again, the same in these computations, right? Okay. If I have here an, what do you call this one that is not yet moving? Okay. So, incident photon, it's the term there. Incident meaning the photon or the light particles are not yet moving. In rest mass. Kaya nga zero pa siya. Ganun-ganun chupa-chucho. For example, the photon is just in his or her, babae ba ang photon? Okay. What's the gender of a photon? Okay. Let's just say this one, her. Okay. The photon has its na lang siya. Okay. Possessive pronoun. Because if you will use personal pronoun, I cannot distinguish the gender. So we just use the possessive pronoun. Okay? So, it's ITS. Di ba ownership siya? Okay? The rest mass of this electron, okay? This na lang, THIS. Okay? Particular pag sa grammar. Okay? So, if this is the incident photon here at rest. Okay. At rest sa ganito, energy at rest, okay, is potential energy. Okay. So, this is the topic that we can remember, the mechanical energy, right? Mechanical energy at point 1 is equal to the mechanical energy at 2. Ganon. So, mechanical energies are composed of potential plus potential energy plus the fractional energy due to friction losses or air resistances, the resisting force. And then usually it will counteract, right? Then some problems will say, assuming negligible fraction, then bingo, you can equate directly. It's energy chuba chuchu. But sometimes you need to account the fraction loss, okay, and the fractional force because it has a coefficient of fraction to resist the applied force or the movement force horizontally. Okay, so mechanical energy at point 1 is equal to mechanical energy at point 2. Mechanical energy is equal to potential energy plus kinetic energy plus fractional energy at point 1. Sila tanan, subscript 1 siya, is equal to potential energy subscript 2. Kinetic energy subscript 2 plus friction losses or fractional energy subscript 2. So assuming there's no fraction at all, so is 0 siya diretso. And then bingo. If there's a mass, there's a velocity, you can compute for chupa-chucho. Okay, so we apply that here also in a theory of the Compton scattering. So the Compton scattering has its stored energy, which is a potential energy because at rest. It's not yet moving. Just like me, I'm sitting here, I develop my potential energy now. Exactly, I'm talking in front of you. But when I stand to get my pentel pen, I'm moving, I have my motion. Subatomic particles. So this is micro particles that we cannot see in our eyes. So the behavior will be different already. So certain. The positioning, the more uncertain. Me, if I will go there, it's very certain. You can see me how I move. That's certain. Certainty. Okay, but for particles, there's no certainty. It's uncertainty unless you will have experimental evidence for that. Okay? That we need to study. Just like this. Okay. Compton scattering experiment. Okay. So this is an incident photon. Chararat. Okay. Okay, incident photon. Oh, incident photon siya. Wala pa siya mulihok. Okay, at rest gani. Okay? So we draw a horizontal axis here, somewhere like that. Okay? Horizontal axis like this. Okay? A straight line. And then we need to draw the wavelength. The initial wavelength of this incident photon. Sa ganitong wavelength, it's just like a tinai sa manok or spiral, something like that. Up, down, up, down, up, down. Something like that. So I'm gonna a spiral or a spring. When you buy a notebook, there's a spring, right? The other one is spring and the other one is not. Just consider that spring. That's also the illustration of a wavelength of a particle for their wave function. Okay, but in a microscopic scale, you cannot see directly in your naked eye. Okay, so I'll put that here. Something like tang, 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 like this. Murag tinai sa manok. This is the wavelength of the incident photon. Okay, so if this is the wavelength address, we consider this as our wavelength initial. Okay, lambda. So Sir Sotero, di man ka ng lambda. Guys, the lambda is just a Greek terminology used to designate the quantity in before in our older times of our scientists basing in the Greece, a country known Greece. So Greek, okay? So the some theta, angle theta, angle phi, lambda, mga ganun siya. Used in before in our older scientists to designate lang siya for easy understanding. Okay, something like that. Okay, and we have also the psi, psi. That pounds per square inch, psi only like this. Tink, tink, tink. Ako drawing ha, psi. Ganon. Psi, lambda, rho, okay, ganon, rho, theta, phi, like this, pi, like this. So this, I think this is Greek symbols. I'm not really that sure based only my stock knowledge. This is symbols from Greece, our old scientists, just like this one. The first is psi. If we a symbol like the psi, but differ in definition, that is homonym. Okay, again, the same spelling but different in meaning, that is homonym. Okay, the same meaning, that is synonyms. Different meaning, that is antonym or support opposite meaning, so that's in English. Okay, so nagkataon lang yun siya nga akadi siyang unang symbol is psi, which is also psi. Okay? Kaya pwede masarang PSI pounds per square inch, unit of pressure. Right? So the same spelling siya. Okay? So lambda ang ikaduha. Ang ikatulo is rho. This usually symbolizes the density thing. Okay, density, mass over volume. So if you see this in the book, a symbol like this, okay, this is a density. Rho, RHO is a symbol of density. Now, theta. Theta is a symbol for angle in trigonometry or in algebra. Okay, angle theta, angle of inclination. Okay, arctangent theta. Okay, arc sine theta, arc cosine theta. The law of right triangles, Pythagoras theorem, right? Involves usually angle. And the second to the last will be the phi. This one, phi. PHI, phi. This is also an angle opposite to theta. Okay, this last is the pi. This is the most commonly and popular known in algebra and trigonometry. Pi is equals to 3.1416. Okay, memorize that all the time, ha? Okay guys, 3.1416 without calculator, na-inject na sa atong brain cells. Okay, so this is the symbols. Okay? Okay. So kung, if I will use this, ay mo kibong, kaya discuss naman ako. Okay? Like that. I want you to be nananay siya sa mga textbook sa science. Okay? Okay. Now, we have the photon will react to the electron. The electron here, guys, is known as the target electron because this is the target of the photon in order for them to combine or to hit this electron so that there will be an energy scattering, okay, between the two. And then this energy could either produce mechanical energy, heat energy, or it could be an electrical energy. Why? Because electrons are more on electrical energy when it will move or transfer to a path. Remember that one? Electrons flow. Okay, so without electrons flow, there will be no current, right? It's just the same story here. When the photon push this electron, normally it will move, then electrical energy will be there. Aside from the mechanical energy, okay, the potential, no, kinetic energy, something like that. Okay, and a lot of energies pa. Kinetic energy also because there's a motion and velocity of these target electrons. Okay, that's why you will familiarize all the energies that I mentioned over and over again. There are a lot of energies, especially in physical chemistry. The first law of thermodynamics, again, the law of conservation of energy. Okay, energy can neither be created, but it can be transformed to various forms of energies. Not limited only to mechanical, chemical, electrical, a lot. Okay? So, ibutan na lang sa inyong mga alimpatakan, the different types of energies. Okay? So, I will mention again, potential energy, kinetic energy, mechanical energy, electrical energy, heat energy, radiation energy, sound energy, acoustic energy, hydraulic energy, geothermal energy, okay, pneumatic energy, 11 na siya. Okay, light energy, 12 na siya. What else? Alat pa siya. Okay? 12 energies pa akong dimension. Okay, internal energy. Okay, gives free energy. 9 na. Okay, what else? There's a lot pa, okay? I just only mentioned 14 energies, okay? Thermal energy. But thermal energy is more basically closer to heat energy, right? Thermal energy. So, it's gonna be like that. Okay? So, transformations of various energies, the first law of thermodynamics. Okay, going back to the topic here. Okay? So, target electron. Okay? And then target electron, okay, ato na siya i-imagine because as I told you, to become an engineer is to have a wild imagination. Okay, so we let this incident photon push the target electron, so it will move in horizontal manner, going to the left, something like that, or forward direction. Then it will push the target electron to move away. Now, if this electron will move away upon contacting or combining with this photon, because photon has its energy and electron also has energy, right? Okay, now if you think through the theory for this, normally the photon has high energy compared to the electrons, or else this electron will not move upon pushing this one. You get the point? You'll be the one to go back by common sense. Okay? The incident photon would have a high energy naturally, even though if it will not hit sa electron, because this electron will move after, or else it will go back, bounce back if this energy is higher than the photon. In that alone, we can move. Okay, there's uncertainty. Why? You could not expect this electron where to go. Here, 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 and this is now what we call the probability distribution of the wavelength that this target electron travels. Meaning to say, the uncertainty of the position and the uncertainty of the momentum of these electrons as this electron received the high energy of this photon light particle. Okay? Because it is very small. But if we put this as a baseball or a ball, then there's a possibility you can determine the exact position where to go. Because that is not a particle, because that is very heavy, right? Maybe it's here, because the weight is very obviously big or high, something like that. Okay, there's a certain position or momentum that you can easily guess. But for the particle, you can never do that. That's why there's an uncertainty. So that's why there's Heisenberg theory of uncertainty principle discovered by Werner Heisenberg. That's why he predicted that one. So in this approach, he used this example, Compton scattering, because this is now a probabilistic approach in studying things. Probabilistic or probability. Toss the coin 100 times. Something like that. Possibility that 88 will be the tail, 77 will be the head. You will never show what will happen or what will come out. So that is statistics and probability. Okay, now the probability term is not sure, so uncertain. So that's why we use the scientific study of probabilistic approach. Okay, the root word for this is probability. That's why probabilistic is an adjective, okay, referring to the probability of a certain object, specifically the particle, how it behave, what will be the specific or what will be the positioning and the momentum of these particles at it strikes with each other, something like that. Okay, you got the point now? Okay, so because most of the study also in physics and chemistry, right? Acetic acid vinegar, the formula is one atom of hydrogen, something like that, C2H3O2, two atoms of carbon, three atoms of hydrogen, and two atoms of oxygen raised to the power -1. So this is acetate. Then plus H, hydronium ion or the H ion will react to the acetate. So it will become acetic acid na talaga siya. Now, if you add acetic acid plus the sugar will never dissociates because sugar is not an ionic substance. This is not a non-volatile solute. Okay, you got the point? So it will just dissolve and retain the T-A-S-T, but it will never produce another because this is not reactive, because this is not a non-volatile solute. It will never dissociates. Okay, but it will just be dissolved. Okay, you get the point? I mean of dissociation, it will go to the acetic acid also and distribute the molecules there. But in here, sugar is not. That's why sugar, okay, if you add sugar, then the vapor pressure of the solution has a little effect. Okay, compared to the salt. You know the point? Because salt is an electrolyte. It undergoes ion to ion chemical bonding. Ionization, the negative and the positive charge. There's ionic bonding. Okay, that's the point there. Now it's gonna be like that. The situation really is for the macro. mixing of chemicals we can see in our naked eye, and it's very easy. We can predict, the sugar will go there and it will coagulate. O ganon. There's a precipitate after I mix this scattering theory. Okay? This is illustration. Okay? That electron will either going there to the top. Okay? Oh my gosh! What's happening? Nakakaloka. Okay, it's going to the top here like that. Oh my gosh. Sorry guys. Here like that. Okay, now it will go like that. And it will go also to the center. Okay? Because we can predict, right? Ganun siya. You got the point? Oh, nakakaloka. You got the point, guys? Ako itong gidownload in fairness. Like this. It goes straight, it goes up, inclined, it goes up. Okay? Incline also. Okay, guys. Now, okay, so we can produce theta and phi here. So, angle phi between the horizontal and going to the top, the electron. So, this is angle theta. Uy, nakakaloka. Or we can say angle phi. It depends naman kung sa imong ikuan basta importante nakasabot jud ka what you are referring to. You can interchange the angle, okay? So let's say the electron side will be the angle phi, okay? Angle phi like this. Okay, and the angle covered by this incident photon. The incident photon will go now to the lower part, something like that. Why? As I told you, higher energy siya, guys. If higher energy usually go down because it's heavier. Okay, something like that. More energy, something like that. If lighter, then how your energy will be higher. You are lighter. You're just having speed very fast because you are light. That the electron's velocity is very fast because the area is very small. So that principle also covers here. Okay, as the photon with high energy bumped or hit the target electron, normally this high energy will go down. Okay, it will go here. Okay, because bigger mass, momentum times velocity, right? And then the lighter particles will normally go up or the scattered photon na akong i-drawing. Ganon. Okay, this is the scattered photon. Photon, photon. Okay? Photon. Tingnan nilang ganun you guys. Photon, the root word is photo, meaning light. Okay, meaning illumination. Another term for light is illumination. Okay, the unit is lumina or flux. Light, candle, Flux, or lumina, Lum, or it could be also expressed in candle. You know candle? That's why candle is called candle because candle is a unit of light. Okay? Why? That's the base. O palitra ko kandila, something like that. Oh no, it's a unit of conductivity, the reverse of resistivity in electrochemistry. So the reverse of ohm is the unit of the resistance, right? The reverse of the resistance is the conductivity. Again, the reverse of the resistivity or specific resistance is the conductivity or the specific conductivity. If the unit of the resistance is ohm, OHM, it will now be reversed as mho, MHO. 1 mho is equal to 1 Shannon. Get the point? Or ohm raised to the power negative 1 in mathematics. If you reverse something, you have to raise that with negative 1, right? So it's gonna be like that. Okay? So that's the unit of conductivity or specific conductance. Okay? So ohm, negative 1, super negative 1, mho, and Siemens. That's why we have Siemens company because their company is derived from the unit of conductivity. Just like here, photon. Okay, that's why we have candle because the term candle is a unit of light or illumination. Get the point? Okay, so things are derived through that. Terms sometimes derived. Well, electron meaning it will, move in different directions. Coil. You have to do different directions such like a circular after here in the top because German siya. Okay. For example, guys, if there is a conductive material very near or nearby to this recoil, so initial delta wavelength. If we put triangle variable that refers to a change in siya, guys. For example, work in thermodynamics. Okay, work is equal to pressure times the change in volume. Okay, meaning to say this is understood to be at a constant pressure, or shall we say in a closed vessel, because in a closed vessel normally the pressure has no effect. Okay, again, in a closed vessel the pressure has no effect because the air cannot go out and the molecules cannot go out in the vessel. So that's why the P is only P there. Work is equals to P, but the change in volume will matters. Okay? You got the point? Because maybe there's an opening downside, it will go to another pipeline connected, something like that. So the volume will be lowering down, going up. Like there's a fluctuating volume for that particular situation. That's why change in volume. So change in volume represented again in the term delta, Greek symbol. So delta meaning, ato dyan ipasok sa atong brain cells, delta means change. Okay? Change of that particular quantity. Since we put delta in letter V, that means change in volume. Gibutang man siya sa kilid. Okay? So if ibutang na mo sa kilid sa temperature, that's also change in temperature. But what we mean, delta or small triangle meaning delta. That's change, difference, and gradient. These are the three terms for that equivalent in science. For example, if the problem will say, if the temperature gradient of the following gas will pass, so ipasok sa imong brain cells na gradient, change na siya. Okay? So, it's just the same with the word change and difference. Okay? Because ang ato mga instructors always use the word change and difference. Panagsara igamit ang gradient. And then in the exam, ilis na yung gradient o maglibog dayon. Okay? So, we should familiarize also the terms, the terminologies. Okay? Like that. So, this is lambda gradient. Okay? Lambda final minus lambda initial. Okay? Or wavelength final minus wavelength initial. Or wavelength of the scattered photon, because the scattered photon is in the final destination, minus the wavelength of the incident photon, which is in the initial destination. Okay? Or not moving pa siya. So this is delta lambda. Okay? Like this. Delta lambda. This is not total ha. Lahira bigong total. Okay? So, final minus initial lambda is equal to delta lambda is equal to, hala, diri na muabot ang postulate equation ni Louis de Broglie, discovered in 1927. Okay, it will be equated now here. Because as I told you, Louis de Broglie find a way that he can find a wavelength of this electron to act also as a particle and a wave. Okay? So that's why his equation will be equated to this. Okay? So without Mr. de Broglie, this equation will not arrive because it comes to him first. Why does arrive this equation? So this is Planck constant h over the mass times the velocity or the momentum. Okay? Times, pag yun siya sa kilid, close and off, open parenthesis, 1 minus cosine theta. Hala. So, Sotero, anong cosine theta man? Kaloka. Cosine theta, because we are referring on the wavelength. We're not referring to the amplitude. Basic theory. The amplitude is referring to the vertical distance. In that manner, we will use sine theta. Okay, sine theta is equal to the opposite side. The opposite side will be normally the vertical that is opposite to the angle. That's what it means by the opposite side there in the law of triangle of Pythagoras theorem. Okay. Angle of inclination. Ganan. So, sine theta is equal to the opposite side over the hypotenuse. Ang opposite side sa drawing diri, guys. Sine di ay, dili man. Okay. Dili man nimo i-compute ang amplitude, imo man i-compute ang wavelength. So, cosine theta, which is angle of inclination, cosine theta kay paano siya? Base over the hypotenuse. Ganon. And the hypotenuse is a wave function, the diagonal. Okay? Like that. And the vertical, supposedly here, kung mag-gawin ko vertical diri, guys, ibutang ta lang matagak sa electron. Makalingaw, no? Okay? So, if electron falls here, it will create a vertical distance. That's the amplitude, right? Like a balloon in the wave, in the sea wave. Oh, go, Alon. So, if it goes up, it goes down, just a vertical distance and amplitude. We are not interested with the amplitude, man. We are interested in the wavelength, the horizontal distance, and the other side hypotenuse. Okay? So, we will use cosine theta. That's why H minus MC 1 minus cosine theta, not sine theta. Why emphasize this? Because in Heisenberg theory of uncertainty is another thing discovered by Werner Heisenberg. He uses the sine theta there because when the light, okay, observe the electron, it will scatter in the screen and it will produce an amplitude magud siya. Okay, and the amplitude there is very important. And here it's not. It's the horizontal siya at saka yung hypotenuse. Okay? Ganon. So that's why 1 minus cosine theta siya ha. Okay? Not sine theta. So muna na atong equation, guys, na gamiton. Okay. Like this. So, incident, final wavelength of the scattered photon minus the initial wavelength of the incident photon is equal to the change in the wavelength, or the gradient of the wavelength of the two is equal to the Planck constant over the momentum, which is the Marston's velocity in the denominator, times, close and open parenthesis, 1 minus cosine theta. Now, the delta change wavelength, pwede na naman siyang tantangon because of the equality sign. Okay? That's why makakompute ka sa mga Planck constant, equality sign. Okay, meaning to say, if the change in lambda is given in the problem, you can equate that directly to the other side, or equate that other also to the other side. Okay guys, when you face the examination in the future, mahibawaan mo siya. Because the problem usually states, the scattered photon, blah, 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 so and so, and the incident photon, blah, 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 so and so. You should detect the terms that usually appear in the discussion. Then it will be outlined in the problem. So you will imagine, this is really regarding about the quantum scattering. You will apply this formula. Okay then. Kato sa kung i-apply ka na siya ganina, may bawaan man sa din mo siya because there's a frequency, okay, there's an energy of an object. You will feel the problem, the applicability and suitability and the limitation of the formulas to be used. Di man ka magpataka o gamit. Okay? Kaya di man siya ma-apply, di man siya mo-holds through the principles and the foundations if you keep on applying the equations because you think they are the same quantities there. No, it's not. You think the suitability, the applicability for that formulas and equations based on the discussion. And here also, it's very clear that scattered, the word scattered, okay? Because this is Compton scattering equation. Now, if this photon-like particles will not scatter, then this will not be also applying. Okay? Unless it is specified. Something like in the problem. Normally kasi siya, the photon will hit the electron with a speed of blah 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 so and so and calculate the wavelength of the scattered photon. In that alone you can compute even though there's no given. Wow. Really, it looks like difficult, but if you understand the principles, you can solve even though there's no data. Why? Because you know the mass of an electron. Okay? You know the Planck constant h. Okay, and you know also the speed of light as it travels, which is 3 times 10 3 times 10 raised to the power 8 meter per second. So, even though there's no given, you can compute what is being asked. You get the point? Yeah, kung dili ka, if you don't memorize those things, nga. Okay? You get the point? So, it's very important to memorize constants. Okay? Like in here. Okay? Here, H usually given by your memorization, mass also memorization, and velocity also. If the speed is not given and it's being asked, then you can also solve for the other variables. It's just like that you will play around in the equations and formulas also. Okay, don't be dependent in one equation, in one quantity only. Na mo to siya kwaon. Sa ito, tuwaron mo na siya sa examination. Okay, so you have to be alert. Okay, that, ganun naman. Diba? Okay, so ganun siya ang mangyayari. Okay, so this is the, memorize this one ha. Okay, throughout this discussion, it took me almost 1 hour, 2 hours, then we will recap the equations, okay? The equations of theory of relativity is equals to the capital E is equals to the mass of an object times the velocity of light, which is 3 times 10 raised to the power 8 meter per second. And this is discovered by Albert Einstein. This is the first formula. Second formula will be the quantum scattering, will be the final wavelength minus the wavelength initial of the photon and the electron that combining with each other is equals to the change in lambda is equals to the Planck constant over the momentum. Okay, ganon. And then velocity is equals to lambda of the electrons times the frequency. Here. Like this. You can play around if you forgot the formula, equation, i-derive na gula siya. Okay, something like that. And then, we have also special relativity. Okay, parent equation for the general relativity, as I told you. We have capital E raised to the power 2, the energy of a photon or energy of an electron is equals to the rest mass raised to the power 2 times the velocity raised to the power 4 of the photon plus the electron momentum raised to the power 2, ganun siya, and the velocity raised to the power 2. Okay? It looks like complicated, but when you do the derivation, you can also compute. Okay, something like that. Or else you can use that also if you want. Okay? But usually it will never be like that, mixing up, right? Usually, it should be simplified. So you can understand really. Okay? Ganun siya. Okay, so another formula that is very important also to consider is the Planck equation of Planck constant. Okay, though this is a Planck equation. The Planck equation is equal to the energy of a photon or a light or combined with an electron also. Okay, meaning to say in equilibrium. Okay, meaning to say this photon energy equation will also be equal the formula of the electron because they are combined with each other according to their energy. Okay? Because the photon also carries this electron, something like that. That like particle, there's a photon particle, right? But the definition of photon is a light particle, okay, that carries electromagnetic force that holds together the electrons in that particular atom. So the term electrons are always there also. So we can say they are being equilibrium with each other. That's why we said this energy of the photon formula will be also equal to the energy of the electron. Okay, even though the books are not saying that. So based on my research, it should be like that. Okay, because it's not spoon feed man sa books. Okay, and sa references in the in the online world, it's not spoon feed. But in my virtual, I take it as a spoon feed. Okay, so there's gonna be electrons. Energy of the electrons also the frequency times the Planck constant. Okay, the same na nasa formula. Okay. So you get the point. Because sometimes in examination also, we will be given a formula. E is equals to H times F. In what equation is this? A, B, C, D. Multiple choice na yun. Equation na rin ipakita. Okay, for example, A is equals to MC squared. Ang question, naaragid siya. Usara, what equation is this? A, what equation is this? B, who discovered this theory? B, letter C, compute for the blah blah blah. In one paragraph, you can compute for 3 items like that. Yeah, multiple choice na. Kung wala ka kabaw sa concept, nga ka. And then magkabuukab pa ka sa libro, magkabuukab pa ka sa handbook, and in which it will take you a longer time to do that. Okay? And it will waste your time. Okay? So better to memorize na lang yun sa mga dali na kayo siyang i-memorize ng mga formula. Okay? It's gonna be like that. That was discovered by Mr. Planck. Energy is equals to the Planck constant. Normally kasi guys, they will never put the word Planck constant also in the question. They will just put H, small letter H, because understood in the lecture of this particular course, for example, chemical engineering, we always deals this as small h in physics, that this is the Planck constant. Now, in the board examination, they will never say small h is equals to Planck constant, c is equals to velocity. Sometimes they will just put immediately a is equals to mc squared. What equation is this? They will never specify na. Okay? That's the makalagot. Okay? So, you will say, that's Mr. Planck equation or Planck's law. Now, if given also E is equals to mc squared, what equation is this? Who discovered, what do you call this theory? Ganun, theory of relativity, discovered by Albert Einstein. That is the relativity equation. Ganun. Okay, so you should troubleshoot this simple, not really that simple, okay, basic foundation formulas. Okay, something like that. Okay. Just like that in the chemistry, right? Specific gravity. Specific gravity of the substance is equals to the density of the substance divided by the density of water. Ang basis nimo ang water. Something naman siya standard na density ang water na 1 at 4 degrees Celsius. Okay? Not 25. That's an exemption because more of the standard temperature in science is 25 under standard temperature pressure, but in density it's not 25, it's 4 degrees Celsius. Okay, correct me if I'm wrong. Okay, they measured the 1 grams per ml density of water and 1,000 kilogram per cubic meter in 4 degrees Celsius, not 25 degrees Celsius. Okay. So this is an exemption also with other standards in science, enthalpy, standard heat of formation, the standard pressure like that. Okay, the standard vapor pressure of water at 25 degrees Celsius, how much? Ting, 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 ting. So that is 23.8 torr. And that 23.8 torr, convert that with another units, ATM, PSI, bar, mmHg, then bingo, you can solve what is the standard unit of pressure at 25 degrees Celsius. Okay? Sometimes, di naman lang hatag ang 25 degrees Celsius. Muana ra sila nga, at room temperature, okay, the pressure of water like this, wala gimension nila ang temperature, but since we know room temperature is considered as a standard temperature, normally range from 20 to 25 degrees Celsius, na wala ka kabang ang room temperature standard temperature din na siya, then di ka kakuha sa value. Kasi paklit sa chemical engineer's handbook mangita ka dito unsa man yung room temperature. Okay, so if you memorize that the room temperature is in the range of 20 degrees Celsius to 25 degrees Celsius, pasok sa banga ang 25 degrees Celsius, maximum side, now you know that that is at 25 degrees Celsius. Okay, so makibaw na kadaan sa vapor pressure of water. Okay, which is 23.8. Okay, torr, T-O-R-R, then it is also equal to 0.0317 bar. Okay, ako lang na siyang di-memorize para dali. Pero i-convert niyo mo, kuha ang gapon mo siya. Okay, 1.013 bar is equals to 760 torr. And then compute, you can compute for the value of the bar. Okay, bar to ATM, atmosphere, bar to, it's very, very, very useful in the process, okay, process engineer job, because there's dealing a lot of parameters there, okay, physical parameters, operating parameters of equipments, vessels, pipelines, like that. Okay, you need to determine the temperature, okay, the pressure, the volume, the density, the mass flow rate, the volumetric flow rate, the specific gravity, something like that, or the boiling point. Okay, the melting point, the fusion, okay, the condensation point, a lot. The vaporization point, okay, something the evaporation. Okay, so very useful. Okay, you get the point. Ganun lang siya. Okay, sa so, kalimti guys, ang katong mga, specific capacity sa ice, sa steam, sa water, sa air. Because usually, mo dyan siya premium ihatag sa problem. Common. Okay, usually mag-start with ani ng mga pure substances. Okay, so it's gonna be like that. Okay, so you should memorize the standard values. Okay, get the point? Okay, that's it. Okay, thank you so much for watching this live streaming. And then if you are not subscribing yet my YT channel, then you can subscribe my YT channel. And then you can click down below for some newest updates of I Am a Singer channel voice. Bye bye, God bless everybody. See you later. Mukhaon sa ako. Wow. Bye bye. See you for another topic. I'm gonna pick up another topic after. Wala na din na siya ma-discuss. Kani siya guys. So scientists. Blanc is the father of modern chemistry. Tang, tang, tang. Then question number 2. Blanc is the father of modern physics. Tang, 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 tang. Blanc is the father of chemical engineering. Tang, 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 tang. Blanc is the father of biochemistry. Tang, tang. No choices. Okay, but in the examination have choices. Okay. The father of modern chemistry is Antoine Lavoisier. Okay. The father of modern physics is Isaac Newton. Okay. The father of chemical engineering is Mr. George Davis. Okay. So some chemical engineers don't know this, but it's George Davis. Maybe we don't know in the board examination it will come. Okay, who is the father of chemical engineering? A, B, C, D, none of the above. Oh, nga. Okay, so something like that. Okay, so the father of biochemistry is Alexander Newberg. Okay, so kana lang siya nga upat. Pwede na. Okay. There's a lot man siya. Something like Niels Bohr, Max Born, N. Roentgen, Pierre Marie Curie, Henry Becquerel, okay, Charles Goodyear, Alexander Fleming, Henry Cavendish, Jules Presley, okay, oh my gosh, ano to? Paul Descartes. Ano nga Paul Descartes? Paul Descartes. Mr. Schrödinger, wow. Mr. Kurt Lewin, I love it. Mr. Planck, Mr. Ludwig Boltzmann, Mr. Avogadro, Mr. Henry, Mr. Reals, Mr. Haber process. Okay, sa ammonia production, Mr. Haber. Okay, so Michael Faraday, Mr. John Maxwell. Okay, asa pa to? Daghang kayo siya ng scientist guys. Oy, dito kumakurot. Uban. It's here. Alexander Fleming discovered penicillin. Okay? Like this. Mr. Werner Heisenberg obviously discovered Heisenberg theory of uncertainty principle. Okay? Okay. Mr. van der Waals. What is the contribution of Mr. van der Waals? Study and equation of real gases and non-ideal gases. Okay, Mr. Dalton. There are two Dalton, the Dalton atomic theory and the Dalton's law of partial pressures in ideal gas law. Okay, that it states that the number of moles is directly proportional to the volume of the gas. So the formula will be N1 over V1 is equals to N2 over V2. Okay, then bingo. You can compute for the volume of a gas or the number of moles of a gas. Okay? Like that. Mr. Albert Einstein, Mr. Isaac Newton, Mr. Albert Einstein, Mr. Louis de Broglie, oh I love it, Mr. Paul Dirac. By the way, who is Paul Dirac? Paul Dirac is the latest scientist, somewhere going to 20th century na siya. Siya ang last. Okay? Kanang badlungon man ni siya, kiato ni siya, pero bright kay siya. Okay, so si Paul Dirac, nag-discover siya sa mga quantum mechanics and electrodynamics. Wow, really? And he discovered also the fermion behavior. Fermion meaning a subatomic particle of the quarks, something like that. There's a fermion composed of electrons and protons, something like that. And the fermions, he said also that these fermions have the quantum magnetic spin, okay, of positive one half and three halves. Okay, because as we all know, we are aware that in quantum mechanics, we have quantum spin for all those particles. Spin, quantum magnetic spin, di ba? If you remember the Niels Bohr, okay, magnetic spin, ganon, magnetic quantum number, principal quantum number, okay, ganon-ganon siya, energy level, o SPDF, KLMN, ganon. Okay, ganon siya. And then, Louis Paul Dirac, mo na yung contribution ni Paul Dirac ha. Okay. Mr. of Bow. Si Mr. of Bow, katong kuan, ingon siya nga, in every atom, ion, or electrons, it will fill, if ILL, the subshells first at a lowest available energy before filling the highest available energy. Magsugod siya sa low. Okay, muna kang off-bow principle or off-bow rule or Mr. Off-bow. Okay, related siya ni Niels Bohr sa electronic configuration sa periodic table. Okay, something like that. Okay, Mr. Hand. Ang kang Mr. Hand naman kay kuan siya katong nag-ingon siya nga ang maximum number of electrons sa mga level, energy level kay 2n raised to the power 2, where n is equal to the energy level. Ganun siya. So, for example, if this is energy level 1, so 2 times 1 raised to the power 2. So there are only 2 electrons can occupy in that first energy level. So that's what he mean in his principle for the Hand's rule. Okay, for example, I have the second level, so n is equals to 2. Here's the formula, maximum number of levels can occupy in each level man siya. So 2n raised to the power 2. So now siya sa second level, so n is equals to 2. So 2 raised to the power 2, 4 times. So 8 regular siya ka-electrons. 8 electrons will occupy in the second energy level in the orbital of the nucleus. If it more than that, it will never hold through. Okay? So it's not following the theory and principles already, or your answer will be wrong already. Okay? So the same. N1, n is equal to 1, n is equal to 2, n is equal to 3, like that. So maximum number of electrons, according from Mr. Hans, or Hans rule, HUND, 2 times n raised to the power 2, in which the small letter n stands for the energy level. Okay? It's not the number of moles. The same with chemistry, ha? Maglibog na po ka kaya ang gamay na n ba? Sa una, number of moles biya na siya. Nakaroon ko na siya, number of energy level. Okay? Ganun. So, Mr. Pauli. Si Mr. Pauli, mo na ang gitawag na ito, Pauli exclusion principle, Pauli Dirac, magnetic spin. But, his magnetic spin will not reach to 3/2 until 1/2 lang siya. Positive 1/2 and positive negative 1/2. Di ba ang electron magtuyok-tuyok siya sa outermost shell? And ituyok-tuyok dito sa electron, ang spin niya either positive 1/2, positive negative 1/2. Maorigi na siya Fermi, 1/2 positive, 1/2 negative 1/2. Ang na-discovered na si Mr. Pauli, Pauli exclusion principle. Because the electrons revolve in the outer in the orbit or in the orbital, okay? At the same time, it will also rotate the same as the 12 planets in the universe. Okay, if they will go to the orbit, they will also rotate in the axis. It will revolve to the orbit, they will rotate like this, like this, like this, like this. Okay, that's why it's very long time to reach 1 year. 1 year is equals to 365 days for the Earth. Okay, so that is for the third law of Johannes Kepler in planetary motion in the universe. So that's the universe. But the universe and the nucleus principle of the Niels Bohr theory, it looks like the same, but the universe is more on the macro, bigger perspective or bigger thing. But in the Niels Bohr, in a smaller thing, because we are dealing with nucleus. Inside the nucleus is a tiny particles called atom. Oh, ganon. So, atom composed of proton and neutron. Ganon. Putol na neutron composed of quark. Quark composed di mahuman. Okay? So we go to Mr. Compton scattering. So, Mr. Compton. That's why we have Compton scattering kat atong discuss last. Okay? So ganun siya. So most of the scientists guys has its own scientific law with corresponding equation and formula. But others also have only the principles and theories but don't have specific formula under their names. Okay? Okay naman sa mga ingon ana. Okay? So combination siya gaya ng yung ideal gas law, 'di ba? PV and RT. Wala may mo angkon anak kang kuan ba na siya. Okay? Kang Avogadro, kang Dalton, o wag siya mo angkon. So that means a contribution of them. Okay, all. So we have pressure times volume is equals to the number of moles times the volume of a gas times the universal gas constant times the capital T in temperature in Kelvin. Ideal gas law. But in the non-ideal gas law, giangko ni Mr. Van der Waals discovery. Okay? That's a Van der Waals equation for non-ideal gases. Okay? Thank you so much, guys. Ni-extend din akong discussion. Thank you so much for watching and passing my live streaming. Bye-bye, everybody. God bless. See you later. Kaloka? Ha?